So hello everybody. I really regret I'm not there with you, but believe me, I'm just physically here. All the rest is there with you, and I wish you a very fruitful and productive meeting. But I want to say a few words about our contribution to Work Package 6. But first of all, I want to thank Jacques Barocas from Tel Aviv University for enabling this recording. Thank you. So my focus is on task 6.1 and task 6.2. Actually, it is our contribution, and mainly to enable the verification and evaluation of the EPO administration by joining all forces and providing the broad insight, and actually enabling a reliable, predictive, and publishable applicable results. So in addition to the very professional statistical group and epidemiology group led by Frido, Tini, and Marit, our contribution is providing an additional insight through our data mining approach. And if I may say, just in general, it's a kind of a blind test. So we take the data, those 4 databases that you enabled us to analyze, we take the data as is, without modification, without normalization, enabling missing data, and we reveal the underlying rule. So the underlying rule, all the rules that we are approving to reveal all rules and a subset of necessary and sufficient rule, as well as unexpected rule, which could provide an additional insight, a very specific insight on the outlier. So this is our main focus, and what I see is a mutual feedback from both sides, from the statistics to our tools, and from our tool with this list of parameters that we identify to see whether the statistical could enable providing that and give an additional insight. So as you see here schematically, as I wanted to show it, so we have the statistical effort, epidemiology effort, and then we have our data mining effort. We identify some parameters, you verify them, you provide some parameters. We're trying to use them as a dependent variable, because what we are doing is identifying a dependent variable and look on all the relevant fields that are correlated with it. And this actually build the rules. So these are the two sides that should work together and provide feedback for one another, and above all is the clinical evaluation. Because when I'm coming up with a list of parameters, the clinician are providing what is evidable, what is well known, and we just eliminate them and go for the more specific and more interesting one. So this is actually what we did, and I just want to take this as an example. This is actually what we did with the ILCAS database, the Revival 3, and I showed it to you already on month 12, these 4 fields. And actually, Tini provided her feedback by analyzing in this nice table, which is more coherent for you. And you can see all the rules and their probability. So we see that the rules are significant. We identify the rules. We show each part of the rule, its contribution, and the rule by itself, as you can see here. And this is the feedback I'm looking for. So then we came up with a longer list of rules, and I just apply and urge to look on that. Maybe there is something that wasn't verified in other tools like the regression or any correlations that you did already in the statistical tools. So these are the lists that we showed. And then we took as a dependent variable the hypert. And here we we have a list of 11 rules that some of them appeared in the statistics provided by Tini and by Ilka, the OPG and the P-selection, and also the platelets that Ilka just sent a very nice paper regarding the platelets. So again, I suggest that you look at that to see if there is anything you didn't know before. And then what I did following the paper that was sent to us last week, first of all, I wish good luck with that, is that we were looking as a dependent variable as a question about the platelets that are more than 232. This was average, actually it's 50% of the data, and this is the list of rules that we found to be significant, essential and sufficient for these platelets. And maybe it could provide an additional, you can see in each rule the small groups, because sometimes part of the rules are very small group, but that's what made it very specific. So you can see the number of records in each rule and the significance. So now let's move to the NecoSet data bank. So the NecoSet data bank, as said before, we had 3 of them. We had the first one, which was 500, and part of the analysis was shown already at month 12. And then we got a bigger database for 5-year administration with 1,944 records. And the last one, which included the censored data, the status. So we analyzed all the 3 of them. We provided some of the rules, and we received answers and feedback from Tini. And actually, the procedure is to come up with the rules, to sit with Dorit and Moshe. Moshe says what is the obvious. We delete the obvious, mainly physical and all those things that are already known. So we have less fields, and we are reanalyzing everything to reveal the new, if and only if, essential and sufficient rules, and then we bring it to your analysis. And then another thing that we did, we took half of the data as a learning set and half of the data as a test set to see how accurate are we. It's not half. We divided randomly according to the probability of the dependent variable. So in this case, in the NecoSet data set, in the new one, the big one, we took as training 1,295 records, and we tested the 649 records that were left as a test, and to see how accurate, as I said, we are. And this is a list of the parameters that I didn't put all the rules, but I think the interesting one are here for your evaluation. And then we analyzed, as I said, the 649 rules, rest of the data, the test study, and we had like 8 misses and 5 false alarm. I just want to say that the false alarm are the error rates that we can play with them, but these were the results, just for your knowledge. So then what we did regarding the EPO administration, because Moshe always said that what is interesting is to see, does the EPO cause death? Or what is the EPO administration influence on survival? So that's what we did. And we looked on all the fields that are related to EPO. So first of all, we were looking on the TH form, the hemodialysis, because this is what one of the fields that we found that is relevant to EPO. I'll show you the rest of the fields in a minute. So when we took TH form as dependent variable, you see very nicely that the EPO appeared. I just took 3 rules as an example to see, and the rules which include more than one parameter. In this case, 3 each, that I thought might be interesting to see the correlation between TH form and the EPO and other parameters. And as you can see here, the number of records here are not very small. The first one is 216, the other one is 99, and so on. And the error probability is almost 0, so they are very strong rules. And then, as I said, we took EPO as a dependent variable, and rather than the TH form that we did earlier. And we were looking on all the rules that are relevant and correlated with EPO. So EPO is 1, so it means that the EPO administration is used. If TH form is 1, the hemodialysis, if we have iron supplement together with the hemodialysis, and so on. And so we took these rules, actually, and we said, okay, this is the administration, not according to the practice, but according to what we found from the data. And we have to bear in mind that this data is not an experimental design. This data doesn't have a control. So we have to analyze the data as is. So we took it, and we assumed that these parameters that we saw here at the EPO are the parameters that are defining the administration of EPO. So we looked on the dependent variable on DUD, like survival, which is the general survival, and we see, and in green you see the observed, and the other one are expected. So we took those that were supposed to get EPO, but somehow didn't get, and we were looking on the probabilities of both groups, and we ignored all the other patients. So we can see here that actually there is no difference in survival between those who received the EPO and those who didn't. And we did the same for DUD1, meaning survival after 1 year, and we did the same for survival after 5 years. So what we see here actually, and we can go into that into more details, and I urge you to look, you know, in other tools as well. This is not the data mining, but just I wanted to see whether there is coherent, significant between this survival and EPO. And we see no significant difference were found in regards to the survival rate for 5 years. So there is no clear evidence or no evidence at all that EPO is causing death. So this is mainly what I wanted to tell you, and what I ask you is really to provide any more data and to collaborate. So I'm willing. Just give me a question, give me a dependent variable. I'll analyze everything that you need. And actually, I want to thank Thomas and Sophie for providing us the data for the mice, and I'm looking forward. We received yesterday more data. I'm looking forward to analyze it and to receive even more data. And I wish you a very productive and fruitful meeting. And bye. Thank you.